right. I think everything's set up properly now. There we go. Okay, cool. Advent of Code day 15. All right, this is the first question in part 2, or the second half of Advent of Code. I don't know, I consider it a part 2. So let's get rolling. All right, day 15, rambunctious recitation. You catch the airport shuttle and try to book a new flight to your vacation island. Due to the storm, all direct flights have been canceled, but a route is available to get you to the storm, to get around the storm. Sorry, you take it. While you wait for your flight, you decide to check in with the elves back at the North Pole. They're playing a memory game and are ever so excited to explain the rules. In this game, memory, that's not my strong suit. In this game, the players take turns saying numbers. They begin by taking turns reading from a list of starting numbers, which is your puzzle input. Then each turn consists of considering the most recently spoken number. Considering the most recently spoken number. Okay, if that was the first time this number has been spoken, the current player says 0. Otherwise, the number has been spoken before, and the current player announces how many turns apart the number is from when it was previously spoken. Okay. So after the starting numbers, each turn results in that player speaking aloud either 0 if the last number is new, or an age if the last number is a repeat. Okay, turn 1. The first number spoken is a starting number 0. Second number spoken is a starting number 3. Third number spoken is starting number 6. Now consider the last number spoken 6. Since that was the first time the number had been spoken, the fourth number spoken is 0. Again, consider the last number spoken 0. Since it had been spoken before, the next number to speak is the difference between the turn, okay, which is 3. The last number spoken 3 has also been spoken before, most recently on turns 5 and 2. Okay, so the sixth number spoken is 3. Since 3 was just spoken twice in a row, and the last 2 turns are 1 turn apart, the seventh number spoken is 1. Since 1 is new, the eighth number is 0, and 0 is last spoken on turns 8 and 4, so the ninth number is 4. Turn 10, 4 is new, so okay. So the game ends when the elves get sick of playing, or dinner is ready, whichever comes first. Oh, it's only 1:30. Dinner might be a while. Their question for you is, what will be the 2020th number spoken? In the example above, the 2020th number spoken will be 436. Okay, so they give you a bunch of examples. All right. And your puzzle, they just give you your puzzle input. Okay, so let's copy this. Let's make a new file, new folder. Day 15. And we're going to create 2 files right off the bat. We're going to create part1.libcoffee. And then we'll also create our input, because we have our input already. We didn't have to click on anything. Plain. All right. And here's some more. Okay, your puzzle input is, so this is the puzzle input. Let's just, I mean, we can either put this in a file like we have been before, or we can just move it down here, down to the end. Input equals, I guess it can just be a string. Okay, and we'll just split that with a comma. So that we're gonna put that in the run section. Whoop. All right. Okay, so we're gonna have defs, tests, and then run, where we already have our puzzle input. So let's use this as our test input. Okay. and then we're going to override that later on with the real input before we run it again. So yeah, what are we doing here? So we are going to be given a new number each time, and we need to determine the next number spoken. But we do that when we've run out of numbers that the elves have given us, I think. So the fourth number spoken is that. Again, consider the next number to speak is the difference. So they get us started, and then we continue on. So they're going to give us, like, what we're going to get is we're going to get an array. So continue is a keyword. we can't use that. What's a good method? What's a good method name for this? And we want to know the 20/20th. So we need to extend the pattern. Extend is also a keyword. Continue is a keyword. Propagate. We need to propagate the pap. Okay, let's just call it prop, which fortunately is not a keyword. And we're going to parse the input of input. And parse input is actually just going to be parse input. It's going to give us text. And we're going to text.split on a comma there, and then we will map parse float to get integers out. So, right. So now we're going to have prop as our propagation function. This is going to take an array of numbers, and we're going to be asking for the target index is what we're asking for. So really what we want to do is we want to take the array, and until we get to the target index, we are going to be just adding to the array and checking the index, checking the last number. Okay, so we're gonna encode these rules is basically what it is. All right, so for I in, so I guess what we want to do is until r.length, we want to be the 20/20th number will be the 20/19th index in the array, so less than target index, and we're just going to say that is 20/20, so we can just pass the array in. And this is array. We should basically tell it it's an array. Okay, so we are going to look at the last item in the array. So we can we'll just pull this out because we're already grabbing array length. Array L-1. So this is the most recent number. I guess we'll just say last is that. And what we want to do is we want to find the last index of that. The most recent time it was spoken. So I know there's index of. Is there last index of? Last index of. Oh, that's for string. Oh, so I mean we could do this. We could do this with string, but I mean we can also do it with array. I like array better. Okay, well there we go. And let's see. So hold on. Let's look at the rules again. First number spoken. Okay. So each time we speak a number, I guess what we want to do is, this is a special case where we are taking this off the array first. And then what we want to do is we want to start adding to the array after, but we can do the comparison before we add to the array. So what we want is we want the next number. So we want to generate the next number. And if there is no next number, the next number is effectively like we just want to recreate adding that last number to the array. So unless next, we're going to say, let's just destructure this. Lex equals array. So this is going to give us a new copy of the array and the next. So this is basically just going to this is going to move us back a step. Okay, and until array length is target index, what we're going to do is, so we know what the next number is now, so we don't need to do that. And what we want to find out is the last index of array. Okay, so the second number spoken is 0, 6. So the last number spoken 6. Since that was the first time this number has been spoken, the fourth number spoken is 0. So we want the last index. The next number is going to become the last index. Or 0. Okay, so the new next is going to become last index of next or 0. Okay, and then what we're going to do is we're going to push next, and then we're going to say next equals new next. And at that point, we're going to want to know what the target index was. So we'll break out of this loop when it reaches that size, the array length. We no longer need to capture L because we don't use that anymore. And then we can just take the last. I guess there's no last. I think we looked this up before. There's still no array last. Like, oops, target index. I guess we can just do target index. This isn't even target index. This is the target the target iteration. So the target index. What is this? We'll just call it target. Target is 2020. So target -1 because it's an array. So this is what we should have. So let's log this. So we're gonna need our usual friends log equals console, and then we're gonna have assert equals require assert. So we're going to log this. Let's just see what it logs. It's freaking out. Target index is not defined. Okay, so I didn't update that. Okay. Undefined. Okay, so that's not good. So let's log what these are and see how many things it's doing. So pop parse input. Let's log parse input. So 036, okay, that's good. Until it's greater than. Guess we need to do that. Okay, array length, and I guess we want to do that equals 2. So it's giving us -1. That's definitely not what I thought we were getting. Oh, I see. Because last index of will give us -1. All right. And then new next equals 0 if new next. I really yearn for like Ruby sometimes. It's greater than 0 or less than 0, I guess, less than 0. Now it's giving us 0. Let's log new, or let's log next every time, just to make sure that we're getting actual numbers. Wow, okay, it's giving us, looks like it's giving us just the wrong answers. Oh, and this, oh, right, because we're not passing in the right target. What's the target that we're supposed to be looking for here? So the 20th number will be 436. So this is what we're, 036. So we're trying to assert that the 20th number is 436. So let's throw this in here. Assert 436 is okay, and we'll just comment that out for now, so it doesn't freak anyone out. Okay, so okay, let's log our next and see what we get immediately now, and let's just comment at the rest and make sure that this is initializing properly. So okay, so the array is 0, 3, and the next is 6. So in here, the array length would be less than the target. So we would log the next one, which would be 6, so we don't care about that. The new next is going to be the last index of next, which would be -1, and then the new next will reset it to 0 if. So what we can do here is we can say, here, let's uncomment this. So this new next is 0. I mean, that's just math.max 0, last index of next. Then we don't need to have another line that does this. This will give us the maximum value. So if it's -1, it'll give us last index. It'll give us 0, and if it has a last index, then it'll be that. And then we're going to push next onto the array. So we generate the new next, we push the current next onto the array, and then we overwrite new next. And finally, we get back the target. So let's do a much smaller target, like 10, and then we'll just we'll map through these. So let's log array and next. All right, 036. Oh, right, so we need to handle 0 specifically, right? So consider the last number spoken 6. So again, consider the last number spoken 0. Oh, right, okay, so we're finding the last index of, but what we want to find is how many ago that was. So we want to find array length. Okay, so new next array length minus new next. So that is just going to be that. So -0. Oh no, so -0 would give us array length. We don't actually want that. So yeah, I guess this is what we do. And this is giving us 8, 036, 2, and what do they have? Fourth number spoken is 0. Since that's the first time, the fourth number spoken is 0. Next, consider again the last number spoken 0. Since it's been spoken before, the next number to speak, which is 4 minus 1. So one number ago. Minus array length -1 minus new next, maybe. I think that's what we want. Or maybe it's +1. Oh, because it's 0 indexed? Nope. Okay, so what's new next giving us? It's going to give us... Yeah, we're doing this out of order. So last index is going to be that. Math.max 0. So this is going to give us either 0 or, oh, this will never find the first one in the array that way. Yeah, we're going to have to actually have to find that. So that's the last index. So now if last index is greater than 0, greater than or equal to 0, then the new next is going to be the current length of the array, because that is going to be equal to the length of the array minus 1 after we've pushed onto it, which we're about to do. And we want to subtract the last index plus 1, I think. Else new next. So what's the rule here? What do we do if it's I guess 0's already been spoken. If it's never been spoken, we return 0. Okay. If it's never been spoken, we return 0. Okay, and then we push next. All right. And is 2 what they're going for here? Yeah, what does this give us? 03604. Oh. This got confusing fast. Whoops. Yeah, I think I closed the YouTube stream window by accident, so I'm sorry if that happened. If that made any had any effect. Okay, so turn 4, so 03603. 03603. Let's 0360. Oh, so this is giving us 4036. Whereas what we want is 3310. Maybe I'm wrong about this. 3310, yeah, okay. 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 So, I mean, this isn't great, but it could be better, but it's working. And let's reset the target to 2020. Let's remove this log, which we don't want anymore. So we're gonna log parse input, and it's giving us 436. So yeah, this is working. Okay, cool. So we've got some more values, and we can just assert these here to see if that they work. So let's do that. Assert whatever is prop parse input that. There we go. Perfect. They all run. Cool. We could actually just do this as well. Prop parse input. Whoop. There we go. And then we can just initialize input for the first time down here. Cool. So I guess what we just want to do is we want to log parse input down here. And what do we get? 319. So let's find out if that's what they're looking for. That's the right answer. All right, continue to part 2. Part 2. Impressed, the elves issue you a challenge. This is probably where shit gets real. Determine the, oh my god, something number spoken. So for example, given the same starting numbers as above, 036, the, how many zeros is that? 1, 2, 3, 4, 5, 6, 30 millionth number. So yeah, I wonder, I guess the question is do we create a pattern? Like, so there's a couple ways we could go about this. We could calculate 30 million loops, and that would create a very big array of 30 million objects. But what do we even care about is in the array that's produced, we only care about the most recent entries that contain all 10 digits. So what we could do is if we ended up going the route where we create 30 million, if we go through 30 million loops, which isn't crazy. I mean, like, computers are fast. That could take a while, but we can do it. If we did do that, then we could keep our array small by recycling. We could effectively, if we find that there's a match, what we can do is we can slice the array and create a new array, which might actually even be slower. But we could do that. We could slice the array and create a new array, and then just add that number onto the end. That might be because we're guaranteed to have, like, if you look at the arrays that are produced, let's log array. Let's log array joined with a comma. Let's do it sooner. Okay, let's set the target to 10 and do it, or let's set the target to 20 and do it, I guess. All right. Okay. Cool. So there are repetitions. See, this isn't even, so in the last 20 numbers, we still don't have all the numbers. There's no 9s, there's no 8s, there's no 7s, like, but the subset of array entries that are going to contain all 10 digits are going to be less than 30 million. So that's one way we could do it. Another way we could do it is we could look for a pattern. We could look for a repetition. And then once we find repetition, we could solve the problem much faster. If, say, it produces an array that repeats every 112 characters or whatever, then, I mean, the next, and we find that after like 500 iterations, then we can just skip forward in iterations of 112 characters, or better, yeah, we can just figure out the mod of whatever's left and go that far into the repeating array. How do we find a repeating array, and how do we know that it repeats, right? So I mean, like, a repeating 1, 0, 2 gets repeated here again, but then isn't repeated in the next block. So that would be like a false positive on repetition. So those are two ways that we could look at solving it. I guess the first thing we should do is just see how bad it is. Let's see just how slow it is. What did I do here? Change the target to 2020. Because it might not be bad at all. I mean, maybe we're overthinking it. Okay, so let's put this in, and okay, part 2. What is the 30 millionth number spoken? Okay. So this is going to give us, let's take this, and we'll throw this in the asserts. Okay, so oops, there we go. Oh god. 30. Okay, I'm gonna keep that number around so I can just copy it. Prop parse input. I guess what we can do, yeah, we can put the number. We can put the number first. Okay, is prop. Let's do that. We should have done that. That should have been the target. All right. So this is going to be our new set of assertions. You know, while we're at it, let's reverse target here as well. Target, and this can be target 2020 is parse input. Cool. Let's make sure this still works. It does not. Never finishes. So prop target comma array. Okay, parse input is mapping parse float. Yeah, why is this now so slow? What is happening? Did I did I change something? Is okay. So now what if I pass in target here? Let's find out. Okay, now, oh, that's parse input that I'm passing it to, right? 319, yeah, okay. Oh, I see, because it's, I didn't put it there. Ha 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 ha. Okay, it's a prop 2020 parse input. And this is going to be 2020, comma, parse input. So then it should finish, right? We have to, lol. Okay, 319. So we got this, and down here, prop, this 30,000, or 30 million rather. Okay, we're gonna turn that off for now. Okay, let's just do one of these. So let's see how shitty fast it is. So it doesn't matter what the default is here because we're always providing it. Let's see if it even finishes. I wonder how long it takes to do 1 million of these. So let's log array length, if array length mod 100,000 is 0. So hasn't, okay, there's 100,000, and it's going to get probably a bit slower as it runs out of memory. 30 million. I mean, there it goes. I mean, this will work. It'll just take a while. It'll take a couple of minutes to get the answer. Maybe it'll take longer than a couple of minutes. Look at that. It seems to be slowing down as the array grows in size. We could naively speed this up by just, you know, keeping the last thousand array elements and hoping that they contain all of the digits. and that would speed up each iteration. That would keep the, not speed up each iteration. That would keep the search time sort of like low-ish and more predictable. That's kind of a shitty way to do it. What we could do is, I mean, we could try chopping it into like 100, 200, 300. And each time we do the chop, each time we do the array culling, we could check to make sure that, yeah, I mean, we wouldn't want to do that every loop. I mean, what we could do is we could search for the last index of all the digits 0 through 9 and take the lowest last index and then slice the array there. I mean, we could do this periodically just to keep it fast. I'm going to do that because it seems to be slowing way down. So let's just let's do that. Let's do it every 10,000. So if the array length is, oh, and we're testing the array length. Oh, so let's also keep an eye on the number seen, or the number called. So we'll start off with 0, and number called plus array length is less than or equal to target. So if the array length mod 1000 is 0, or I guess we can say unless. So this can be call array, and what we'll do is we will, for n in 0 up to and including 9, let's log and just make sure. Okay, this is giving us 0 to 9. Good. So for 0 up to including 9, what we'll do is we'll look for not for. What we'll do is that map, or better yet, yeah, map array, and then that's going to be n, last index of n. So we're going to map over and find the last index of all of those, and we'll do min this. These are going to be the last indexes. Actually, here, I'll put it there. So we're going to, you know, I like the spread at the front for things like this when you're passing it in. You can do it either way in CoffeeScript. And this is going to be the lowest index. And then what we'll do is we will num called equals. So this is going to be the lowest index plus 1 is how many we were going to chop off. And then we're going to say array equals array dot slice. Or I guess we can just say array last index and forward. So let's see if this works. Okay, and then, oh yeah, we're gonna do so we're calling the array here, and also we should do 100,000 will log the array length. Okay. Oh, it's not the array length. Oh, you know what? Yeah, so this is going to give us, every time it reaches a multiple of 1,000, then it's going to call that. And then, okay, so what we should do is we should log these things as well, that this is happening. Log calling called, or I guess we've done it at this point. So we're culling that many. And okay, we're calling a lot of them. So let's please stop. Oh shit. I should set maybe a smaller limit. I think my computer's unresponsive. Monitor. Okay. I think we might. Okay. No, I got it. All right. It canceled. Let's start with 300,000. And okay, and then we'll say less than called plus array length. So we'll log array length. Okay. Yeah, okay, so even 300,000 is killing this program. Maybe this is just too much logic to do. I mean, it's doing stuff. I wonder what the monitor is saying. OBS, by far the biggest CPU hog. Okay, so we got a couple of nodes running. I wonder which one this is. Force quit. I think it might have been that one. Force quit. Okay, so we probably force quit this one. Okay, so let's get rid of this log and just see how often it hits 100,000 now. And we'll see how many nodes we have running. Just one using 100% CPU. It hasn't hit 100,000 yet, which is pretty surprising because the last time, I mean, like, it hit 100,000 within. Oh, num called is +1. What the hell? Plus equals. Whoops. Okay, let's that explains so much. Okay, let's try this again. There we go. Okay, assertion force equals true. Maybe it's just plus equals lit x. No. Okay, so what's this? Assertion error. False equals true. So, oh, right. Okay. So let's try some of our previous assertions and see if these still work. No, they don't. Okay, so this should have been giving us, so this is for 2020. No, still not. False equals true. So why is that? So unless num called plus array length. So this is just, we're just logging the array length. And we're never even getting there because it's not getting to 100. Okay, so let's try 1,000. So that is getting us to 1,000. And unless array length mod 1,000. So it's only getting that high a couple of times. And then, okay, so math min, let's log what these are. Oops. And I guess we should join, let's join with a space so we know. Okay, so, oh yeah, math min. That's not what we want. We don't want to join math min. What we want to join is just that with a space. Okay, so these are the last indexes. So the minimum of these would be 808, I think, and the minimum on here would be 210. Oh wow, that's actually quite a while without. Maybe 1,000 is too low. But it is doing it. It's doing its job, which is it's calling the arrays. And then so log for, this is going to be a length before length here, let's log them both at the same time. And then this is going to be after. So, and then log before and after. Array size. I mean, maybe this is just a crazy thing to be doing. I don't know why we even necessarily need to do this. So the array size before was 1,000 and after is 192. So we're definitely chopping a lot of stuff off the array, which is good. And in this case, chopping only 210 off, which is here. Oh, you know what? We actually probably want to chop index -1. Okay, it's still giving us an assertion error. And then, oh, it's because, you know, it's because we're getting target -1 and we don't want to, okay, so we actually want to array dot length -1. That's what we want to do. We want the last one. Okay. So what? So this is our weird culling method. I mean, this isn't even that good because it's still going to compute them all. Let's array length. Let's index next. I'd like to sort of target -1. You know what we can do is we can just say ret equals array, and then we can return ret. And that does not work. Why does that not work? It should give us the last one. It's greater than or equal to target. Let's log. Oh yeah. Whoops. Yeah. Try that. Okay, so this is actually what we want. We can destructure it. And this is still crashing. So what is this crashing? Okay, line 63. It's just the assertion is not true. So let's log and see what that is. 127. Let's see what the second last. Let's see what these are, and then we'll log that, and then we'll return last. So 21, 27. Yeah, this is okay. So num called, maybe num called. I'm calculating num called. So plus equal by last index. So the last index. This would throw it off each time. And then what are we looking for here? 436. We're still not getting 436. The last index, then I'm called +1, or would that be last index -1? This is just a terrible. So this is okay. So last index going forward. So if the last index is 500, so array size before, and then so in that case we would have, okay, array. So now we have an array of 193. So we would have chopped off 808, and that's what last index should have been. Log last index. Oh no, we're not. We are chopping off. Okay, so num called would be array.length minus last index. Is that correct? How about we call it array R? So that gives us -1 +1. I don't know what I'm doing anymore. So last. Okay, so this last index would be 808, and that's, oh no, the last index, that is how many we're chopping off. Okay, so it's still not giving us the correct answer anymore. Which is odd. If we increase this to 10,000, this will never run, and it gives us the correct answer. So it's definitely in here. And until num called. So num called equals the last index, and this is we actually want a last index +1, don't we? No. We do want the last index going forward. So that'll give us, okay, so the index that we're chopping at. Oh, my brain's not working today. It's not a great thing for advent of code. So let's let's figure this out. We got this array. Okay, cool. And so we're finding the last index of 4. Or no, how about the last index of 5? So the last index of 8. How about that? So 0, 1, 2. So we found the last index of 8. So we want, okay, and then we want to say we want to call, so the last index of 8 is 2. So we want to call these two and be left with array 2, okay? And then that means that we've called 2, right? Okay, so num called is that last index. Because if it was last index of 0, then we wouldn't have any and we wouldn't call any, okay. So that's correct. So num called starts being 0. And then until num called plus array length. Is it that stupid thing? No, because that was working. Let's see. Okay, yeah. False. And so if we disable this, it just keeps going for a long time. Okay, that's not good. Oh, right, until false. Right, that's why. Ah, crap. I killed it again. No, die. Please. Thank you. Okay. That is not where we want to break execution. We want to, unless false and. So, okay, well that's, oh, unless true. Okay, so this is not giving us the right answer anymore. That does. So we're doing, so by messing with num called in the, and the, by messing with num called, we are actually breaking it. So we don't need to map those anymore. Huh. So we're overriding array. We're getting the last index of all of the numbers, and we're taking the smallest one. and we're adding that number to the number that we've called, and then we're chopping the array down. So why doesn't it work? Let's then log what the new last index is. So 1, 2, 3. So that's 3, 4, 5, 6, 7. So we've got a last index of 0, which would be the first one. Good. There should always be a last index of 0 if we're logging that. And wait a second, there wasn't here. Maybe that was the problem. Maybe there was no last index. Yeah, let's try that. And let's log before and then after. So before calling and after calling. So before we have a number for everything, good, and then before we have a number, oh, and there's the 0, and before we have a number for everything, and there's the 0. It's still giving us the wrong answer. I mean, if we do it every 10,000, it should work because we never reach it. And if we do it every 500, we should break periodically because we don't always have a 0. So maybe that's what it is. Maybe it's just not finding a last index for everything, and it just grabs the minimum. But it is. What if we do it every 50? Yeah, then it loops forever. Okay. So I don't understand why this isn't working. I mean, this isn't great either because this just gives us a predictable amount of time until the end, which is good enough if it works, but it doesn't seem to be working. Like num called plus array length. So we're overwriting array. Let's num called plus array length. Let's see if doing it every 1,000 loops will make a difference. No, it doesn't. It actually just doesn't do anything. It gives us a different wrong answer. Okay, so I mean, that's a good hint that calling it is actually just destroying the array somehow. Okay, so we push, and then second last, we log second last and last. I mean, we could just do array length -1. Why is this so hard? Okay, so we don't need to do all that. And we can just replace that. Okay, you know what, let's just do that as well here. Okay, it's still giving us 319. So why is this so broken? Okay, so this bit of code here is definitely doing something to piss it off. Okay, so if the array grows to be over 1,000, grab the last index of every number from 0 to 9. We get the minimum of those numbers, so the smallest one, we add that to num called. And let's log, no, not there. Let's log num called, and then called. Okay. 808. So 0 have been called, 808 have been called, 1000 have been called. That seems correct to me. Num called plus array length is greater than or equal to target, and target is 2020 in this case. And then we're logging, we don't need to log that anymore. So finished, we're still getting 0 when we should be getting 536. Yeah, we stole that from here. Should be getting 436 and we're not. That's just super weird. Like, I don't understand what it is about this that is broken. I mean, one thing we could do is we could just comment this out and try to get the answer. And maybe just like, yeah, let's just log every 100,000. All right, well, that's 1 million. That'll log every 1 million. Let's do log every 100,000. We'll see how long it takes. And this will give us the answer. It'll at least give us an idea of how long this is going to take. I mean, there's got to be a smarter way to do this. I don't think Advent of Code has ever had a question that takes minutes to process. That usually not a thing, but usually they go bigger than that. Usually it's like, you'll either be able to solve this within a couple of seconds or it will take, 80,000 years. And this will probably just take several minutes. So it's in that weird gray area where it could conceivably just be a hard problem that you need to crunch. Mind you, this is going to take like how many minutes? Like an hour? 30 minutes? That's just a long time. I'd rather mess around with this than, and even then it's still going to take like 30 minutes. Okay, so there's got to be a better way. If anyone's watching and anyone has tips or hints that they want to give me on how to make this faster, I'd appreciate it. What we can definitely see so far from just like these, what we can see from like how often it's culling things, it doesn't seem to be finding a pattern or be culling the same number of things each time. So I don't feel like there's necessarily a pattern involved. And if there's no pattern involved, then I don't really understand how we can skip work, which is what we want to do. We want to avoid doing work. Like, is there a way to find out, I guess, the numbers, the last time the number 0 gets called, or I guess so it says it's 0. So 0 only appears here when, oh, look at that, new next equals array.length. Okay, so I mean that's why this fucked up, num called plus array.length minus. Okay, so that's, I mean that's probably why it was breaking. It wasn't this code here that was doing it. It was let's try that and just see if it's any faster. And also we should, so just doing that, let's assert that that works. 8:15, that is not the answer that we wanted anyway. Okay, so so if it's greater than 0, then new next equals, no, that's actually correct. It does want to do array length minus last index. Yeah, because that's the array that it's operating on. Yeah, so I got nothing. What we can do is we can just chop it down by 10,000 every time it's greater than 10,000. We'll just say array equals, this is awful, 10,000. There we go. Let's try that. Okay. And this is going to give us array length num called. So we'll say num called plus equals to 10,000. So this gives us a different answer of 6. So it should be 436. Let's see what it gives. It gives us 436. 1,000 and what's this? What? 99. Oh, it still gives, yeah. Okay. I mean, I don't even think we're getting to this number in 2020. So array length. Oh, unless if. Yeah. Okay. 436. I mean, we can try that. We can try and do this. Oh no, that crazy assertion. Yeah, we can just chop it off. I wonder what we should probably do is we should probably like do the timer. We should do like, see if this is actually start equals like whatever it is, time. Lol. Okay. And then was it node, was node's timer thing again? Node time end, or I know there's console time elapsed. Yeah, I think we should just go console log. What are they saying? I mean, you can just do elapsed time. Process HR time. So that's high resolution time. I don't think we even need to be that new. Like we just have to count the number of seconds really. New date. I always forget JavaScript. Let's just get Unix timestamp. Yeah, is it date now divided by 1,000? Okay. Okay. New date get time? Expressed in seconds. Yeah, okay, well, let's do that. Start equals that. Cool. And then we will do log minus. But we're not going to do it here. We're going to do it every we'll do it here. So unless num called plus equal plus length mod every 100,000. Okay, and of course we're not doing anything, so it's not gonna. So we can just do it here, and we'll see how many seconds it takes to do each 100,000. That's the idea. And then what we can do is we can, that's 10,000. That's 100,000. Oh, do we need to put these in? Okay. It seems to be happening a lot faster. Let's log that. See, oh, this is like if array length is greater than. Oh, so num called here isn't even correct. This is just chopping it down. So I mean, like this is useless. It equals 0. So this is gonna. So what we're gonna do is we're just gonna there plus equals 1, and this is gonna give us a way of saying, hey, every 100,000th iteration, let's log the iteration. Okay. This seems to be going suspiciously fast. So maybe it's just keeping the array small. I mean, it's possible. Okay, let's just run this. 100. Let's do it every million as well. So this is just chopping off a fixed number. Like we're basically just keeping the array. Oh, so this is awful. So if the array length is over 10,000, then we are immediately just chopping. Oh, we're keeping the last 10,000. So I mean, probably what we want to do is we want to be less aggressive about this. We want to keep the last 10,000 if the array gets over 20,000, because otherwise what it'll do is it'll just keep it at 10,000. So as soon as it goes above 10,000, it'll just chop off the last one. I mean, we could do this with a rolling window. We could, like, whenever we push onto the array, we could pop off the beginning, or we could, what is that, shift? If the array is at a certain size. I wonder if that would be faster. I mean, we only have to get to 30. It'll probably be in less than a minute now. I wonder if this is even going to work. I guess we're going to find out. I can just let that run. Like every time we push, what we could do is we could just array shift if the length is over a certain amount. I wonder if that would be faster than destructuring. I mean, let's find out. Let's say array dot shift shaft array shaft. And we'll just do it at 10,000. And I guess what we want to do is we do want to log the number of seconds. So let's do that again. Is it minus start? Minus start. Okay, so we're 12 million now. And then what we do is we would not do this. Okay, let's see how long it takes to get to 1 million now. Okay, so 7 seconds to 1 million. So this performance curve should be roughly linear. So this would take 210 seconds to get to 30 million roughly, or 200 seconds to get to 30 million, which is like how many minutes is that? 3 and a bit. Which I'm okay with. Like, it's not the best, but it'll work. And then I guess the other question is, what if instead of doing array shift, we actually did this bullshit? We did occasional array shifts effectively. So let's see what that performance profile is. So this is about 20 seconds per 3 million. And let's see if it's any faster doing occasional array shifts. So it looks like it's slower doing occasional array shifts. Yeah, like not dramatically slower, but noticeably slower. So I'm okay with the first way we had it. And rather than comparing this length all the time, what we could do is we could turn on shift mode. But I don't feel like it's going to have a huge impact. I mean, we can find out. So if not shift mode and the array length is greater than 10,000, shift mode equals true. So let's turn on shift mode, whoops, shift mode, and then we can array shift if shift mode. Shift mode. I can't type. Okay, so whoops. There we go. We're gonna turn on shift mode. And we'll see how fast that is. So it was 21 seconds. Okay, so let's see if it's faster now. So 7 seconds. So let's see if now it's any faster. I mean, comparing an array length is not that complicated. So nah, it doesn't do shit. All right, whoops. All right, let's just let this run this time. We'll get an answer, and we'll see if the answer is even correct. I guess what we could do is we could run this assertion. This is a lot of assertions to run. If they take 3 minutes each. So let's just run this against the input and see if we get an answer that's even correct. So thank God we're logging. Okay, good. So let's just see. Let's wait. Let's wait it out. Cool. While we're waiting for that, we can look at refactoring part 1. So what do we got? Parse input. I mean, it's really only just splitting and then mapping on parse float, but you know what, like I feel like it's doing enough to the input that it warrants its own method. This propagate method propagate is probably just a terrible word for this. But yeah, okay, that's fine. And it grabs, so it destructures this for the first calculation. It wants to know what the last one is, and then it pretends that we're about to add it back, so it can do its calculation. Until the array reaches the target, which is 2020 by default in this case. What are we doing? So we're saying, give me the last index of the next number. So if last index is greater than 0, this always bothers me about index of, is like, oh, it's one of those annoying things where it returns -1. -1 if there's no index, which like is super annoying, because you can't, like, it's not, a negative number is not falsy. And I understand that 0 is falsy, and is a valid answer for, oh, we found it in the first element of the array. But like, it kind of pisses me off that things like index of or last index of don't return something more false, like false, for example, or undefined, because you always have to check how big the value that you got back was, which is super annoying. Like, you can't just, like, you know, if you know, it's like if it's not undefined or whatever, it always has to be like, oh, if it's greater than 0, greater than or equal to 0, which is super annoying. Anyway, so that's what we're doing. We're doing that, so then it becomes the difference, otherwise the difference is 0. And then we push that on, we swap next for new next, and we start the cycle again. And then at the end, we just return the array. And this passes all our tests pretty quickly, and then it gives us our puzzle input. Okay, so we got to 30 million, and we seem to have blown right past 30 million. So we screwed something up, unless it wants 300 million. No, 30 million. So, okay, we're definitely... So num called. See, we're testing. Yeah, there you go. So it's iteration that we want to stop on now. So that's not good. So num called, we don't even use num called anymore. So iteration equals 0. So until iteration is greater than or equal to target. Yeah, okay, well, hooray. We gotta restart that. But I mean, at least it's going fast enough that we can just restart it. Oh, hi, what's this? Assert false equals true. Why is that the case? Oh, because, yeah, we got too far in. Okay, so 7 seconds to there. See, all of that work, and we didn't even get an answer that we could test. How could we do this faster? I feel like 3 minutes is just long. All right, let's think of ways that we could do this faster. So we clearly don't need this. We don't need to log that. So we can move that. I wonder if it would be faster too if we kept the array smaller. I wonder how big can this window get? I wonder. Anyway, right. So how could we make this faster? So patterns, I don't know if there's a pattern. I feel like maybe there might be a pattern eventually, but I didn't see one in the first like several thousand, it seems, because every time it was chopping off what the smallest number was, it was like a different number and in the hundreds. So I feel like, also knowing advent of code, I kind of feel like this would be a large non-repeating number, like pi. So there's probably a pattern or a wave determining the pattern that I just am not aware of. Like maybe this is one of those things where it's just like, well, according to, you know, Bob's theorem, you can calculate the xth number according to this rule set by doing some weird math trick. And if that's the case, that's cool. I guess I'll find out what Bob's theorem is after the fact. But I wouldn't even know how to search this to find the name of Bob's theorem. And 3 minutes, I feel like, is a reasonable enough amount of time that I'm happy to actually just run it and then find out what the answer is, which sucks. So maybe what I'll do is, like, I can't think of a better way to do this. Maybe what I'll do is later, when I find out what Bob's theorem is, I can refactor this code to use Bob's theorem. And I'm using the term Bob's theorem as just sort of like, you know, a placeholder for whatever that math trick is. But in the meantime, we should have an answer now, and the answer is 6. Okay, so let's find out if 6 is what they're looking for. The next number spoken is 6. Is that really it? That's not the right answer. Okay. So it did all that work and it gave us the wrong answer, which is very upsetting. It's possible that 10,000 just wasn't a big enough window. So what we could do is we could try a larger window, like 50,000, and we could see, well, one thing we could do is we could look at the last one. So we could see this is the last. I guess we're tracking next. So we could look at what next is each time. And see if they change depending on the window size. So let's do that. And this is every million, so let's do every 100,000. 42, 12, 0, 212. And let's do this every 5,000. So 42, 12, 0, 212. Yeah, so this changes dramatically if we go to 5,000. What if we go to 20,000? Also changes dramatically. So I feel like maybe our windows aren't big enough. So 79, 29. Yeah, so that's interesting. So they change every window 40, so 50,000. So at some point I would expect these numbers to just be the same. Oh, but this is array length. Right, so that's why. This is the only time we're using array length. It is. So that's super fucked. I don't understand why that's different. So when we put in the wrong answer, it did give us a hint. So let's check that out. It's not the right answer. If you're stuck, make sure you're using the full input data. Some general tips on the about page, or you can ask for hints on the subreddit. Okay, let's do that. About varies. So let's see if there's a tips solution mega thread that's going to have spoilers. Okay, there's a lot of memes. How often each number is spoken. Oh, this is interesting. This is a neat chart. So let's look at that. That's interesting. Hint. Come on. Where's the hints? Where are my hints at? Nothing says hint. Yeah, where are we going? On a Commodore 64. Okay. That's part one. Okay. Day 2. Yeah, we want day 15. Day, I guess we can look for just day 15 rendered animate day 18, 2015 to 18. Trying to solve the wrong problem and wondering why your output just won't match up. Yeah. Day 15 is the lesson this year. Solve the problem you have. I inexcusably missed the blank solution at first, but was able to solve it with a sort of blank on, oh, that was day 10. And today, all I have to do is solve part 2, was change the input and wait for a bit. This is not the case for everybody. Okay, this is interesting. So this is an interesting topic. Okay, so this sometimes feels a little dirty. I'm so eager to get to the answer that I'll do whatever works for that particular case. Seems like the inputs are built with that purpose in mind. Even if you don't know the piece of theory that will make the problem easy, you can still solve it with a suboptimal but not always brute force approach in a timely fashion. Okay, then you come here and you feel dumb because there's a better way. So yeah, does it always work like this? Yeah, it does. It does always kind of work that way, I feel. What number are we at here? What are we looking for? Is iteration over target. So we're only at 4.3 million and we're still doing that. Maybe, I mean, maybe this chopping thing isn't great. So let's see how long it takes without the chopping. So this is every 100,000. So it took 4 seconds for 100,000. Yeah, with the chopping down to 10,000, it definitely was a lot faster. So I feel like the key here is Well, we only care about the last iteration of next. Okay, so maybe that's the solution. Maybe what we want to do is, rather than shifting, we've got the last index of next, and then we're pushing next. So then what we can do is we can array equal slice last index. No. That's not correct, is it? So 2, if I find a 2 again, yeah, no, then I don't. I still need to know the minimum of every possible number. Oh, and these numbers aren't just 0 to 9. This is every number. So I guess what I want to do is I want to unique it. So I could maybe do this with a set. I don't know. Let's see if this is faster. Oh, it's breaking. Breaks very quickly. Unique is not defined. Okay, so unique equals require underscore. So let's try that. And then we'll see. What we should do is we should see if this works for these as well. I guess unique will give us the first. Yeah, so that's bad. Okay. Yeah, because unique would give us the first version. We want like kind of unique last. So the rolling window is a lot faster because the array is small enough. What we could do is we could make a map, and every time a map of every number. So rather than having an array, what we could do is we could have a map of every number, and the most recent iteration it was seen at. So I guess what I'm thinking is we could have like a map, and that map for this array input 036 would be 036, and it would be 012. So this would be the iteration that we're on. And then if we want to add a number to this, like let's say, we're going to go O again, then that O would now become 3. And then that way we can, because all we really want to do is we want to track the most recent index that we saw something at, and then we can just use that to look it up. So let's try that. Instead of taking an array, I guess we'll take the array, and let's just completely fuck this up. Okay, so this is what our map is going to look like. Here, let's keep this around for posterity. Okay. So for A and R, so we're going to have our map, and then we're going to say A index in R. We're going to say map A. So this is going to be our number, I guess, and is better, and equals index. All right, so then now what? Okay, so we're going to start our iteration at 0, and we're going to update our iteration as we feed in the array. And then what we're going to do is we're going to do until iter is greater than or equal to target, and then we're going to do iter plus equals 1, but we're going to want to do that at the end. And then, so what's the question asking us? It's asking us, okay, so we were trying to find the most recent for next. So the most recent now is just map of next. And you know what, we should do this array next thing, because this is, we'll do that here. Okay. So that will give us the first couple of entries, 0, 1, and then 2 will be next. Okay, so until iteration is greater than or equal to the target. So map next, this is going to give us the last time we saw it. So if last index equals that, then we want, oops, the new next is going to be the difference between iteration minus that. Else new next is going to be 0. I mean, we're just going to add a key. So instead of array push next, we're going to say array, not array, what was it, map of new next equals iteration. Okay, and then we're going to do that until iteration is target is greater than or equal to target. And what do they want at this point? They want to know what that was. So if iteration is target, we want to tell it we want to return new next if iteration is target. Otherwise, we're going to assign it, we're going to bump the iteration, and then we're going to restart the loop. So let's see if that passes these assertions. And it doesn't. So 58, 16. So 58, it broke the first one. So let's see what we get if we log that. Let's turn all these guys off for now. They're just going to make us feel bad. Okay, so return new next if iteration is target. Okay, so we're starting at iteration 0. Map, let's log map here. So 0, 3, okay. And then, so why is it calling prop a second time? Oh, it's calling it down here. Well, that at least runs fast, but that's clearly not the correct answer. So that's log map there. Let's log the map until iteration is greater than or equal to target, and the target's 2020. So new next, and let's log map. Okay, so this doesn't seem to be here, log iter. Okay, so it's logging that, and it's getting to 2020. If the iteration is the target, we do this. Otherwise, map new next. Or I guess we want map next is iteration. Where are we using map? Where are we using next? Okay, so that's the current index of next. So, oh, right, we want to assign next and then new next equals next. Oops, because that's what we were doing before. It's still giving us undefined, and it's still not adding to the map. Okay, so if map of next log li, okay, else log nope. Let's see if that, so we find nope once. Okay, so we're getting next here, array and next. So we're creating this map. We're assigning the number equal to the iteration equal to the index here. And that seems to be correct. So 0, 3, because that's what we're putting in here, 0, 3. And the next one is 6. So here we should log nope, and we don't. And if iter is target, so let's log iter target. Okay. And so that's weird. It broke before we got here if iter is target. Until iter is greater than or equal to the target. Okay, so it would have never done until iter is greater than the target, maybe. Okay, so it seems to be always putting 6 as what it should be. So next, so maybe it's saying, oh, next is new next, maybe. Next equals new next. Okay, so this is at least giving us, find 2020, whoops. It's giving us an answer. Anyway, the answer is wrong, but it's giving us an answer. The answer should be 436. But it's filling out the array, which is great. I'm very happy about that. Okay, cool. So 0 is last seen 2016. Fine. God damn it. Run. Okay. New and find 2020. Where is 2020? Oh my god. Okay, we're gonna have to scroll, or better yet, let's just not log. Let's not log that. Let's not log that. We're just gonna log map. Okay, copy. So go in here, find 2020. So 2020 doesn't exist. 2019 does exist, and that was 94. So let's put this after it adds it to the next. Okay, and then return. Oh, maybe it should be returning next, not new next. 458. Is that what we wanted? No, 436. So we still not correct. So let's find out. Let's see 2020. Where's 2020? 458 was 2020. And what do we want? 436. 436. What was 436? 436 has never been seen before. So, okay, this is incorrect. So we want to add next to the map. Or do we want to add new next to the map? Okay, I'm confused again. Right, push next. We add next to the map is what we would do, and that's set to the current index. And that'll tell us how recently it was seen. Array length -1. Oh, minus li. So the new next is either going to be the iteration minus the last index, or it's going to be 0. So next equals new next, and then iter plus equals 1. So I guess what we can do is we can start with those shorter ones, or we can just, yeah, what was this example? So this is 036. We can just do 10 iterations, and we can see what we get there. So 10, and then we can just toss out next every time. So log map iter index. So let's log n, and then here we'll log next every time. And then, okay. So 036, and then we get 00102, which is totally not what we get before. So 6, 0, and then we get 03310. So after the 6 should be 03310, and that's not what we're getting. So we are clearly screwing something up. Log new next. Still no. So the map of next. So if we've seen it before, we want to know the difference in the last time that we've seen it. And that would be the current iteration minus the last time we've seen it. That would be the new next. Otherwise, we don't. Okay, so then we've got next here. And what we want to do is next equals iter. Map next equals iter. So then we assign it to the array, or not to the array, but to the array. And then if iter's target, we log the map, and we return next, which was the last number that we saw. And then we reset to new next, we bump the iteration, and we keep going. Okay. This kind of makes sense to me, but I guess it doesn't. So what can we do? So 0, 3, 036. So it's not even giving us the right thing. We should be logging next here. 036. So next. So new next is being calculated incorrectly because that's where it starts to go off the rails. So log, so yeah, it's saying it can't find next. And that's because it's, okay, so the current next equals iter minus the last scene. Is this not returning a number? Oh, I will cut a computer. No. Well, that's last index. Last thing's a parse float map next. No. Map next. Because it's giving us these, I don't know if they're actually integers or if they're strings. So parse float. Yeah, this isn't a thing. Okay, so log next. All right. Just getting confused at this point. So we're logging the map on the way in, which we don't care about. 036, and then 036, and then O, yeah, and then 3. 03603. So maybe setting it to iter is the problem. It should be iter +1 or iter -1. No. And okay, we start with iter here. There, plus equals 1. Yeah, that's fine. And then until iter is greater than target. So log iter next. I guess we should do next iter. So 2, 3, 4, 5. And then this is the map that we've currently got. So let's get a comparison over here. So when we do, I mean, we can just grab this prop and call it prop2. So let's call this original prop, OG prop. So we'll call OG prop, and then we'll log some new lines. Okay, and then in OG prop, what we'll do is we will okay, so for A and R, we're gonna log A, and then we're gonna log next. So what's this? 0366. 0366, is that correct? I mean, it must, oh no, because we want to do it after the, right. Okay, so 036, 0331. 036, this should be 331, and it's not. Okay, so iteration is 0. We're mapping. We seed the array, or the original, and then we can say until we reach the target, which is 10. We're logging next. The first next is 6 because we just pulled that off. And then we want a 0 to be next, and that's true. So maybe what we're doing is we're saying new next is 0. Oh my god, that's why. If 0 is greater than, Jesus. No, if 0 is less than. Or if 0 is greater than or equal to. Okay, so 03603, 03603, but then that should be 3, 1, and we're getting 0, 0. So let's take a look at OG. What we're doing is we're saying we're getting the if it's greater than or equal to 0. Okay, and here we're grabbing li. Where's li? If li is greater than or equal to 0, then we're saying new next is array length, which is iter minus the last index. Otherwise, we set it to 0. And then array push next becomes map next equals iteration. Okay. So 3, 3, 1. Okay, so this is now giving us the net right before out. Okay, beautiful. So we should now be able to assert that 436 is the correct assertion error, false equals true. So no, it's still not liking that. Let's log that. And it's giving us 0. New next. No. Okay. What are we doing? Oh, David James has joined this part 1 or part 2? Part 2. It's part 2. And so what I've done is, like, originally I was just using an array, and now I'm using an object. And I'm getting the same output for at least the first 10, which I think is good. I guess what I should do is I should then log ogprop. I should log ogprop and see what I get. And that gives me 036033140. So that gives me O. And then down here I'm getting 2. 402. I guess what I want to do is I want to say until iter is greater than or equal to target, and then that gives me O. And then what if I just log that? That gives me undefined, but it prints out 436, which is what I want. What happens after the first 10? So I mean, after the first 10, it should theoretically keep going. What I'm doing here is I'm creating an object, like a map of the last time we saw something. And I'm just logging the map here, which appears to be undefined for some reason. Where am I? Like log map. Is this the only log that's going on in here? Fine, log. Here, log, map, log, oh, next and iter. I don't care about these anymore. So this is now giving me return next and log the map. So, oh, but this is going to be is target -1 is what we want, I think. And that gives me 436, and that is what we're trying to assert. Okay, so is target. Okay, so we're going to return next if iter is target. Otherwise, we're going to keep going. So I think this might be it. This is passing that, and we'll see if it passes all of these, and it does. I'm still logging something somewhere. There. Okay. So now I guess the next thing to do is see how this holds up under 30 million iterations. And it looks like it's taking a while. So that's one thing that I was doing earlier, is I was logging every so many iterations just to give myself an idea, track progress through iterations. Yes, I mean that's totally what I want to do right now, is I'll log iter unless, what are we at? 1 2 3 4 5 6. So that's, well, let's do 100,000 mod 0. Okay, we'll just see how. Okay, so this is iter mod is, or unless it is. Yeah, okay. Okay, so this is giving us, okay, so we got to 1 million. Okay, this is going like, it's going reasonably fast, but we're not at 30 million, and it seems to slow down. You see, yes, not. I mean, I guess I could just wait. So it's logging every 100,000. But it seems to be slowing down dramatically. And I'm worried that it's going to get exponentially slower, or geometrically slower. I guess that's the correct term. But I guess we'll find out. Yeah, I got nothing. I don't know. Is this a crazy way to go about this? I don't know. I don't know what your solution looked like, but like, did it take minutes? I feel like there must be like a math trick to make this go a lot faster. And I just don't know what that math trick is. But I guess I look forward to looking it up later. Yeah, well, I'm a third of the way there now. I think there's a lag, a video lag. I'm close to 10 million. So I'm 1/6 of the way. To answer is a big hint, but yes, a long time. Okay. Yeah, I mean, I guess I can just wait. I'll just wait it out. So I was trying a naive approach earlier with like a window where I was keeping the array small by just chopping it off if it grew above 10,000 arrays, and that ran in 3 minutes. But of course, I was naively assuming that all the entries in the array would be the numbers 0 through 9. So you looked for patterns. Okay, so that's interesting, because I thought about looking for patterns, and I remember when I was doing that array chopping thing, I wasn't seeing patterns, but also when I was looking for patterns with the array chopping thing, I wasn't looking for the right pattern, I guess. I was only looking at the numbers 0 through 9 rather than all the numbers. So this does seem to be getting slower. So looking for patterns. I mean, yeah, I wouldn't even know what types of patterns to look for, because the numbers aren't going to repeat because the keys are getting larger. Oh, you wasted a lot of time looking for patterns. Yeah, okay. Yeah, that's exactly what I was looking for. How much memory do I have? I have 16 gigs of memory, which I'm sure is enough to hold this object in memory, I hope. But I mean, that's really up to V8 because it's Node that's doing this. So I'm at 12 million. I mean, I can just let this run. And I guess what I'd want to do is I would want to log the answer if the assertion passes. And you know what, like, I'm gonna kill this. So I know roughly how fast it goes, and it's acceptable to me, so I'm gonna restart this. But with with this new input. So at least at the end, if we get a number out, we can try to use it. So we can remove all that. And yeah, what do we got? So this passed the assertions, at least for the last stuff. Okay. And what are you saying? What kind of Mac are you on? So sadly, an Intel Mac. This is what's this? A 2018 MacBook Pro. So it's relatively recent. I don't think it has like the upgraded processor or anything, but it's relatively 2.9 quad core Intel Core i7. I doubt this one's that good. This is a 2.6 i7. So it's, I mean, it's close because it's got 6 cores and it's 2.6, but Node is only going to use 1 core. I mean, it's within striking distance. Yeah, it would. I mean, it would be cool to. It is a newer model, I guess, 2018. So maybe it's marginally faster. I don't know how much it's gonna help really. But yeah, it's like if yours took minutes, then I feel okay with taking minutes as well, because I don't know that there's one like, oh no, you should be able to compute this in 2 seconds. I'm fully expecting after I finish this that I'm going to go onto like Reddit and take a look, and then people are going to be like, oh yeah, here's how you do it in 2 lines of code in 1 millisecond. But I'm also sure that that's going to be like some math property that I don't really understand. Okay, I mean, it's going. It's moving slowly, but it's going. I was optimistic after part 1 that this might be a fast day. Yours took 10 minutes? Okay. Oh, mine slowed down more than yours. Okay, that's not, I mean, that's not good. So they do get progressively slower. Was yours using roughly the same idea of using an object to store the last time it saw an integer and just like looping through 30 million iterations? Was that like the rough idea, or did you have a completely different approach? It's always weird talking over YouTube because I know there's a delay and I don't know what the delay is. So I'll like ask a question and then like 3 minutes will go by. Okay. All right, so I'm at 10 million. It's been a couple of minutes. Don't need unique anymore. Just be careful not to restart this. I could move map and iter up into here, so I don't need to do that. I guess I could do that for day 1 as well. What do I have in here? Right, next, new next. I don't have any things in here. That's fine. All right, 11 million. Yeah, I feel like this is probably gonna hit the 10 or 15 minute mark. I got my coffee. Now I don't. Okay, David's saying, I just used an array to store the last position a value was seen at. An array to store the last position. So no complicated data structures. Store the last position a value was seen at. So I guess you had probably the inverted array from just having the whole array of numbers. So you would have had an array where it's like the fifth one would represent 5 in my object, I guess. Yeah, I mean, I think we're basically doing the same thing, except I'm using an object key instead of an array. Just in case the numbers get big and it doesn't like the whole sparse array thing. Yeah, I mean, this worked for 2020. This guy, so I'm assuming it'll work for 30 million as well. I just have to wait. It's one of those times you wish there was a fast forward button on life. Oh, you started with an object as well? I wonder why did you pop? Yeah, I'm gonna pop this chat out so I can make it bigger. Whoops, too big. I'm just putting this on my second monitor so I can see it. So you started with an object and switched to an array. Did you find the array to be much faster? If I wasn't scared of turning this off because we've already invested, so oh wow, we just jumped to 20 million. Holy shit. Well, that was fast. It seemed more efficient. Object keys are strings. Yeah, that's true. But you were just trying things? Yeah, okay. I don't know if that was good that we just jumped. We just jumped about 8 million in like a split second, and now it's slow again. But I feel like, yeah, at this point it could be done at any moment. So I'm excited by that. Yeah, here we go. I'm just gonna put this here. Where is here? Just trying to dock this to the side of my monitor. Why? Come on. There you go. That way I can still see. There we go. All right, we're at 21.4 mil. Yeah, I know. That's what I'm worried about. Oh wow, and it just jumped. So 24. I don't know. This seems like a suspiciously low number. I'm afraid. Okay, cool. So let's. Yeah, it doesn't. You guessed 6. Well, it's higher than 6. All right, let's give it a try. That's the right answer. All right, yay! So it worked. Okay. Wow. That was kind of a pain. Thanks. So I'm not going to leave these assertions uncommented because that's ridiculous. Yeah, I should time it and time it with an array. I think that's what I'm going to do now. Is I'm going to do this. So this is going to be the object one, and then I'll do one with an array, and I'll time it to 2020. So this is going to be prop array. So the map will be that, and the map of next is iteration. So I wonder, yeah, let's just quickly time it with these 2020s. Yeah, and I think that's exactly what all I need to do is just change the one to the other, because it's the same syntax for adding to an array. So let's do these. Okay, so first of all, so we got prop and prop array. So let's put these in, and let's just start with one. Prop, and then prop array, and see if they both work. So they both do work. That's good. And then, so let's grab time and time in. time end. I mean, whoops. This will give us tomb end. This will give us like millisecond accuracy, time prop or object, and then time and object, and then time array, and then time and array. So let's try this. So object is slower than array, at least for the 2020s. All right, thanks David. Yeah, I also overthought things. Thanks for the help, appreciate it. It looks like object is about twice as slow as array, so array might even be better. Let's just see anecdotally if it, whoops, if it works faster. Yeah, it totally does seem to be working faster, and even as we, holy shit, yeah, this is dramatically better. So that's a great suggestion, David, of using an array instead. That'll speed it up by about half. So we can remove those. I'm gonna leave these uncommented, and I'm gonna remove the logging, even though. Speaking of cook, my laptop is getting very hot. Need one of those M1 MacBooks. Yeah, I'm gonna remove this. I'm just gonna comment out the log, and then turn that into proper. Well, I guess proper array is the one that we're gonna keep. So let's keep that one and just rename it to prop. And then we can comment out the log. Cool, but it's already at 7 million. Yeah, this is definitely much faster. So cool. Yeah, let's just take a quick look over the code, and then if we're happy with how it looks, then we can commit it. So what is map here? Yeah, map, I mean, it's exactly what it was as an object, which is just, we're storing in the position of the number what the last iteration that we saw the number on. And so we can just do it's greater than or equal to 0. So I mean, like, really, we can just, if we find this, but of course we want 0 to count here. It's greater than or equal to 0. So I mean, like, if it exists, we want to, yeah, so we want to do that, I guess, is what we're just, if it exists, I guess. What did we have before? If it's greater than or equal to 0, is that what we had? Yeah, if it's greater than or equal to 0, I mean, and that's fine too. Otherwise, new next. Okay, cool. And we have iter minus iter would be equal 0. So what we could do here is we could say that, or, oh no, because that wouldn't count 0. Do that, no. I'm happy with this. This reads okay. And then this is where we assign back to the map, and then we return next if iter plus 1 is target. So that's going to be like if the next iteration. So let's do that. If iter, so we'll get ready for the next loop, and we'll return next if we've hit it, and otherwise we're going to overwrite next. So that should work. Cool. And then we can run one of these assertions just to make sure that it still works. Yeah, good. All right, and I feel all right about this. This can be our logging line that we can leave in if we want to have some input. Otherwise, we're good. This is day 15. Definitely getting harder. All right, so day 15. So I mean, what we could do is we could backport this entire method to day 1, but I don't feel like we need to do that. So let's throw day 15 in there. Day 15, and then of course we want to add it to the README. 14, 14, 14, 15. This is going to be, really? Okay. There we go. Day 15, and then what is the, just grabbing the ID for this YouTube video. Is that it? Video, I think this is it. Okay, and this would be index 14. Cool. And let's see what that diff looks like. So we had to add extra space for rambunctious. And all right, so add day 15 to our README. Cool. So big thanks again to David, who joined and helped me think through that last portion. And otherwise, I will see you guys tomorrow. So thanks for sticking around. If you've stuck around this long, appreciate it. And I'll see you for day 16.